Hello, it's Jim from JetsonHacks.com. Today we have the Intel RealSense 3D camera. It is an R200 model. Let's get started. Let's take it out of the box. Intel RealSense 3D camera for tablets and longer range uses. That's us, longer range. Open. Ooh. Okay. Let's see what we have here. The USB 3.0 cable. Let's get it. We have the camera module. Legal disclaimer, get rid of that. Huh. Intel confidential. No, I won't share that then. It's pretty spiffy looking. My understanding is that there are 3 cameras inside, a left facing and a right facing IR camera, an IR projector, and a RGB camera. The RGB camera is 1080p at 30 FPS, and the IR cameras give you a depth field of 640 by 480 at 60 frames per second. The range on this particular camera is a half a meter to 3.5 meters inside, and when you go outside it will see up to 10 meters. Let's take a look back at some of the other 3D cameras that we've used over the last couple of years. This is an Xbox 360. I think this was one of the first ones that we hooked up to a Jetson. Kind of get the form factor. For an embedded or a robotic application, it has issues. Probably the foremost of which is it's rather large and has a lot of extra wiring and proprietary connectors. So it has a wall wart and a bunch of wires. So in comparison, the RealSense camera is about this large. This is big, this is smaller. The next one we used was an Xbox One Kinect version 2 sensor, which was about the same size as the Xbox 360 sensor. A little square. Put this aside. But it has the same issue with wiring. So there's even more wires and boxes and stuff that go along with it. And it still has proprietary connectors on it. So in comparison, this is big, this is somewhat smaller. One of the next sensors that we used was an Xtion from ASUS. Its technology is very similar to the Xbox 360 Kinect. It runs off a USB 2.0 port, so you can see it's quite a bit smaller than what the Kinects were, both in height and depth. As you recall, we used this on our little Jetson bot, Turtle bot. In comparison to the RealSense, it's big and this is small. But you can see it's much more manageable. You can imagine that being on a robot, especially a ground-based robot. The next sensor that we looked at was the structure sensor from Occipital. So you can see that it's quite a bit smaller than what the ASUS is. About half the width or so. It's close to the same depth. The structure sensor does not have an RGB element in it, so you do not get a image stream from it like you do out of the Kinect and the ASUS. This uses the same technology as the Kinect 360. The Kinect, the ASUS, and the Structure are all for indoor use. They use infrared illumination techniques to sense depth. In a size comparison, you can see that the RealSense is a little bit longer than the structure sensor, but its depth is quite a bit smaller. So I'm still going to say this is big, this is small. A popular camera on the Jetson right now for robotics application is the ZED, made by Stereolabs. It uses 2 RGB imagers to provide a depth map by disparity. So that means that you can use it outside since it's all just optical, there's no infrared involved. And you can also use it inside. Kind of in a size comparison, it's about the same size as the ASUS is. One of the nice things about the ZED is it's easy to mount. It has a mounting hole right here that's basically the standard size of a photo tripod screw. In comparison, here's the RealSense. So you can see that the RealSense is quite a bit shorter lengthwise and relatively skinny in comparison. To boil it down, this is big, this is small. All the other cameras that we've looked at have their cables attached to the camera itself, which can be a little bit of an issue if you're mounting the cameras on a robot or a drone. One of the nice things about the RealSense is that it has a detachable USB cable, so you can select different sizes depending on your application. So here's the one that comes with it. You get a relatively short cable, but you can put on third-party cables, so that's a pretty nice addition. Now all these cameras have different types of capabilities. They have different resolution sizes, different frame rates, and this isn't an apples to oranges comparison. This kind of gives you a feel for the mechanical packaging of the cameras and how it's changed as the technology has progressed over the years. To give you a sense of scale of what this might look like on our little car project, for example, here's the actual camera itself. So you see it's a little less than the width of the TK1. The connection is pretty simple. You just plug it into the USB port and you're good to go. So you might be asking yourself, how much does this thing cost? You might guess 100 million billion thousand. It's slightly less than that. It's about $99. So let's go hook it up to some software and see what it looks like. This is a config UI example. Let me start the capture. You can see that we have the RGB stream here, the depth stream here, and the 2 infrared. You can see that our depth stream is a little bit wonky. And you can also see that our infrared images here are a little bit blown out. So let's turn on the auto exposure for the infrared. You can see that our depth stream cleaned up quite nicely. You can also see that there are patterns on this infrared here. This is because we're inside and we have the infrared emitter on. So let me show you what happens when we turn that off. Turn off the emitter. This would be useful when you're outdoors and the sun would kind of ruin your pattern. So you can see that the depth map kind of loses some of its definition. So I'll turn that back on. You can also see that there's a wide variety of parameters that you can set in this developer's version. I can change the color brightness, for example. You can see that I actually have on a gray shirt. A little bit of contrast, so you can actually set your parameters just like a regular camera. So there's the color camera settings, there's the IR camera settings. You can set all sorts of auto exposure and depth parameters. So there's a wide variety of things that you can actually control in this camera, which is a little bit different than the other cameras that we've been using. So here's the obligatory point cloud. You can see that I haven't tuned any of the parameters here, so it's kind of spotchy. But you get the idea. It renders quickly, so it looks like it's doing at least 25 frames a second or so. So that's good. So that's a start. This is a multicam example. I have two R200s hooked up to the Jetson TK1. Can I give you a sense of the depth sensing? So black chair, it's not very reflective, and it has holes in it, so you can kind of get a feel for what it looks like. It is actually two cameras. Let me disconnect one here. It's not a real good selfie stick. So it looks like you have enough bandwidth to handle at least two of these cameras. That's an idea. Why don't we take a look at the activity monitor. So you can see that the CPUs are pretty busy, but this is not optimized code. We do most of the conversion, the color conversion, just in regular C. So we'll go through and add some either neon or CUDA to help with that.